Hello, this is Christine Halsey, and today we're testing the connectivity with Traceroute. We're going to test end-to-end connectivity with the Traceroute command on a PC, and we'll compare that to the Traceroute command on a router. Okay, so first we're going to click PC1. We're going to open the desktop, and go to the command prompt. And we want to ping 10.1.0.2, which is PC3, and destination host unreachable. Okay. From the command prompt on PC1, enter the traceroute command. And on a PC, it's tracert. On a router, it's traceroute. Okay, so we want to trace the route to 10.1.0.2. And it shows me where it's gone to and how far it gets. Okay, so I use Control-C to stop it after a little bit. And we want to see the first place it got to was 10.0.0.254, which should be the address of our router here. So I'm actually going to cheat a little bit and use the examine tool on the router, and I can come down to the port status summary, and it gives me a list of the IP addresses and what port they're off of for the router. Okay, so 10.0.0.254 is the gigabit port of this router, or its default gateway. So it does have a gateway, and it is getting to that gateway. The next stop is 10.100.100.2, which puts it in this network. Again, I can look here and see that 10.100.101 is this serial port, so I'm betting that router B's serial port is .2. Okay, the other side of it is .5. See, this is the 0 network, so this one's 1 and 2. 3 is the broadcast address. That makes this network 4. This should be 5 and 6. All right, and it is getting to 6, which is going to be the serial port on router C. So router C serial port 10.100.100.6 is the last destination it successfully makes it to. Okay, let's see what else they want us to do. Compare the last address reached with the traceroute command with the network address listed in the topology. Well, they didn't really list anything for us, but the furthest device from the host 10.10.2 with an address in the network range found is the point of failure. Okay, so it didn't make it to this network. It didn't make it from this network to this network. So somewhere between these two networks, we have an issue. Okay, click router C and go to the command line prompt. Okay, so on router C, I'm going to issue Show IP interface brief. And I must have went too far. There we go. Okay, so in this interface brief, it shows me that 10.100.100.6 is up. And then the other address is 17. Okay, that sounds a little strange because we've been working. This group here was 0, so it had 1 and 2. Its broadcast was 3. The next group was 4. It had 5 and 6, and its broadcast is 7. So that would make this group dot 8. So that would make the two interfaces here need to be 9 and 10. Well, it shows dot 17. So let me do the same thing on router D. And I'm right, it is 10. So if this is group 8 and this is 10, this should be 9, not 17. Okay, now we need to correct the problem, so I'm going to go to interface serial 0, 0, 0. Oh, first I need to go into configuration mode, then I can go to the serial interface and set the IP address of and it should be 10.9 with a /30 subnet mask. So let's put in the correct address first. 10.100.100.17. Okay, now for the subnet mask, it's a .32, /30. So that means I've got 10 bits. No, I'm sorry, 2 bits that I'm using for the subnet mask. So 1, 2, 3, 4, 5, 6 are 1s and 2 of them are 0s. And I wasn't in binary when I put that in, so I got to do it all over again. 6 of those are 1s and 2 of them are 0s. So that makes our subnet mask 252. So it's going to be 255, 255, 255, 252. Okay, make sure I do a no shut since that's what I forgot to do last time. And I'm an idiot because I gave it the same address that I didn't want to give it. So I'm going to go back into my interface. It shouldn't be 17. That's what I found. It should be a 9. So now we've given it that IP address. Some days. Alright, and now I'll do the show IP interface brief. And now I have 6 and 9 are both up, and now we can check our connectivity. Okay, so again, I'll come back to PC1. Actually, let's redo the traceroute. and trace complete. So we fixed the connection problem. And they want us to now compare Traceroute on the router. So we'll open up router A and go to the command line. And we want to trace route to 10.1.0.2. And it says compare the outputs from the two. All right, so it was at the default gateway, so it didn't have to go there, but its next hop was 10.100.2, and then 2.6, and then 2.10, and then the mission was completed. Now, the only thing that looks funny here is how long it took it to get to that next hop for the first. So it didn't take that long to do it here. Okay, there's also extended trace route. And as part of the verification, use the extended trace route on router A to increase the number of ICMP packet traceroute sends to each hop. Windows traceroute also allows the user to adjust a few aspects for the use of the command line. Okay. So on router A, on the command line, enter the trace route and hit enter. Okay, and notice that just the traceroute command should be entered. I'm trying to figure out what they're doing here. So I'm on router A and we entered the traceroute. Oh, just the traceroute command should be entered. Okay. I guess I misunderstood that part. Because at that point, well, no, I can do that there. I'm wondering why that didn't work unless I trace route. Nope. So it didn't work. Why am I not getting what they want? Okay, so I do have to come into user exec mode. So I typed enable, and now I'm going to do the trace route command again. I want to enter the IP protocol 10.1.0.2, source address 10.100.101, no, 3-second timeout, probe count of 5, minimum time to live 1, maximum 30. That keeps it going for at least 30 hops. And again, it shows the same sequence that we saw in our other table. Okay. How many questions were answered with non-default values? the IP address, the source address, probe count, so 3, and how many ICMP packets were sent by router A. Probe count specifies the number of ICM packets sent to each hop by traceroute. Okay, so 5. A higher number of probes allows for a more accurate average round trip time for the packet. Still on runner A, they want us to issue it again, but this time change the timeout value to 7 seconds. Okay, so I'll do traceroute 10.1. Okay. Let's try that again. 10.1.0.2, 10.100.100.1. No. This time they want us to make the timeout 7. I'm going to leave everything else as is. Okay, did our timing change much? Yeah, a little bit here and there if you go back and compare bits to bits. Yeah, timeout parameter can be very useful. If it took longer than 7 seconds for that to happen, it would have died. Actually, it just goes away from the network. Thank you very much.